Welcome. We're here to provide you with some registration advice for this coming year as you're thinking about programs either in biomedical engineering or chemical and biomolecular engineering. I'm Heidi Martin, one of the faculty in the Department of Chemical and Biomolecular Engineering.
I'm Professor Seidel in the Department of Biomedical Engineering. First, we'd like to speak to you about is the engineering core. And there are two components with respect to that core. They're the basic math and science courses that are required, and secondly, there are the specific engineering courses that are required. So what you'll see in this first slide on the engineering core are the listing of the 4 math courses, calculus and differential equations, the 2 physics courses, the basic chemistry courses, and other things that are required for all of our students at the university. That includes the SAGES courses and communication courses specifically for engineering. And then there are also humanities and social science courses. All of these provide a broad background for your future. On the next slide, we emphasize the specific courses that are taught by faculty in the School of Engineering and are indicated by ENGR. And again, these are taken by all students regardless of the program in which they are interested in. They provide a general background, and the idea is that we want our students to have this base of understanding because we don't know in the future what they may be doing. And it's very important to have a strong basis for any kind of career.
Many of our students come in with advanced placement credit based on a variety of courses. Listed here are several of the most common situations that students will have either regarding their math or science requirements. Specifically, you'll see credits listed for different types of calculus exams. For instance, if you were to get a score on the AB exam of 5 or 4, you would skip 1 semester of calculus versus if you were in the BC exam, you would skip more than 1 semester. And you can see there's other listings for the other subjects. Some of these requirements, of course, are decided by the departments, specifically humanities and social sciences. There's just a general guideline listed here. But you'll be provided with the specific equivalencies of what transfer credit you will get. The university also honors credit for IB exams or also credit taken, for instance, classes you may have taken at a local college before you leave high school. So all of that is handled by our admissions office before you come. You may be concerned whether you should or should not take that credit when you get to the university. And we do have a 2-week time period at the start of each semester where you can potentially register for either if we talk about calculus, for instance, you might register for the first semester and the semester, attend them both and see which one you feel more comfortable with. That way, you're welcome to take the credit and go to the more advanced course, or if you're not as comfortable, you can go back and take the earlier course.
With respect to biomedical engineering, we have a typical program that is outlined for you. Keep in mind that this program does not assume that you have any advanced placement credits. And every student is an individual, and the program will be designed specifically to meet the needs of each individual student. So in general, what happens is, in the first year, you're going to be taking the courses, basic courses in math and physics and chemistry, and some SAGES courses as well. Then in the second, now also in the first year in biomedical engineering, there's an option to take an introduction to biomedical engineering. This may be for 1 credit or for 3 credits, but it's not required. We want the students to have an opportunity to explore various options in terms of their interests, and it's difficult for many students to really know a priori what is going to be most of interest to them and what would fit in with their particular academic strengths. In the second year, we have a sequence in biomedical engineering called physiology biophysics, and that provides students with a background from the cellular to the organ systems, dealing with a variety of topics, but with an engineering perspective rather than courses taken through a typical biology program. The more advanced courses in biomedical engineering are taught in the third year and in the fourth year. So in each of these years, you now will have more advanced courses, not only in biomedical engineering, but you'll also have them with respect to the specialty areas that are related to the tracks within biomedical engineering. So with respect to the tracks, there are 4 major tracks. Each track has a different kind of emphasis. The biomaterials engineering track has an emphasis more on chemistry. It also can lead to minors in polymer engineering or material sciences. The biomedical devices and instrumentation track has a more electrical orientation, and obviously it can lead to a minor in electrical engineering. With respect to biomechanics, it has a mechanical emphasis and leads to a minor in mechanical design. With respect to the biomedical computing and analysis track, there are 2 aspects. One is the systems engineering and the other one is a computer science minor, and they both emphasize software rather than hardware. But regardless of which track students will take, there'll be a number of biomedical engineering courses that will be common to all of them. Typically, in the specific tracks, there are 8 courses that are particular. And now, with respect to the next slide, we're going to talk about some frequently asked questions. First of all, what is the difference between a biomedical engineering major and a biology major? Well, in terms of what they study, it's quite different. In biomedical engineering, there's much more emphasis on mathematical and physical concepts at a more advanced level, and those are applied in terms of the various applications associated with clinical aspects in particular. With respect to career opportunities in biomedical engineering, typically, we have most of our students will go on to careers at a bachelor's level initially in some commercial enterprise. Very often, however, they will go on to higher studies, master's degrees or beyond, after some work experience. Now, in some cases, we also have, and a number of our students also go on to graduate study in biomedical engineering, other engineering areas. They also have, many of our students go on to graduate programs that deal with management. And a certain number of our students also will use the background in biomedical engineering to pursue medical school and a career in clinical medicine. But those careers typically will be definitely involving some aspects of biomedical engineering and will give them a special advantage. Now, for those students who are not sure what track they are interested in, the idea is that they would have an opportunity to take an optional course in Introduction to Biomedical Engineering to help them become familiar with the various aspects of the field. And keep in mind that whatever choices a student may make in the first and second year of the program, those choices are not irreversible. Students may change majors as well as changing tracks. It is not a particularly difficult point to do. Of course, if a student makes a change in a later part of the career, then there are additional courses that would have to be taken. With respect to the computational courses. In biomedical engineering, the emphasis is going to be on the use of MATLAB as a computing language. However, for those students who are particularly interested in computation, or in particularly the computational track, they would take also the course given in Java. So in this case, students would have essentially background in both of these areas. And finally, with respect to the BME curriculum, what students often want to know is, will they be able to finish with a bachelor's degree in 4 years? And the answer is yes. You will be able to finish. We pride ourselves in making sure, to the extent, unless you have some special difficulties, that you will finish in 4 years. The differences may come in some cases for students doing a study abroad if they cannot find the appropriate courses that will be transferable. But again, we help them with that. And in some cases with respect to co-op opportunities, depending upon how long they take in terms of their co-op opportunities, there can be 2 of those, and each of which is a semester and a summer. So if a student takes 2 co-op opportunities, then typically the student would have to take more than 4 years to complete the degree.
If we now turn to the chemical engineering program, you'll see here also a sample program for the first year in chemical engineering. And as you should hopefully notice, it is incredibly similar to what Professor Seidel showed for biomedical engineering, and that is definitely no coincidence. We've purposely set up the curriculum so that all the engineering programs have a common first year with some minor changes depending on the program. And this, again, allows a student the flexibility to consider these different flavors of engineering without having any kind of penalty in terms of not taking courses soon enough or having to take extra courses at that time. So if we look at this program, again, you still have the math and science requirements, the chemistry, the physics, and the SAGES requirements. In our case, there's a few, so the differences you would see here. First of all, we do recommend that you take the first semester of Physics 121, in the fall semester, so that you have the opportunity to then take the second semester in the spring, which would allow you to finish physics within the first year. If you don't choose this option, it's not going to be catastrophic, but that's definitely what we prefer. Also, we offer a freshman level course as well. It's ECHE 151. It's a 1 credit hour course that has a laboratory component to it. And it also serves the purpose, similar to what Professor Seidel talked about with EBME 105, providing you an introduction to the major, the types of material that would be important to, in our case, chemical engineers, and gives you, again, a feeling for whether you really do want to consider pursuing that degree. For chemical engineering majors, it is a required course, but if you're not yet sure, you're still welcome to take it as a means to help you make your decision. As you move along in the chemical engineering program, again, you start taking required chemical engineering courses in the second year. We wanted to bring up some unique aspect of our program, which is our breadth elective sequences. And these are not tracks as biomedical engineering has, but they are a smaller subset of courses, 3 courses specifically, that cover a variety of topics. And what's listed here are the set of approved sequences, although if you have an interest in something outside of this, you can also design your own sequence. These sequences can be then potentially used as part of a minor. And what's interesting to note, you'll even see biomedical engineering listed here as one option. And I think what this points out is the same as what Professor Seidel pointed out about tracks, is that there's a lot of overlap between these different areas. So even though you have a primary interest, in our case in chemical engineering, you can still explore these other interests in other areas and get a minor in other departments. And I believe we've had students currently that are chemical engineers that are getting a minor in biomedical engineering and vice versa.
Yes.
Move on to the next slide. We also have some frequently asked questions about chemical engineering. One of those being, of course, what is the difference between being a chemical engineer and a chemistry major? I have a personal interest in this question since I was both of these majors when I was a student at Case. And really one of the main differences is the fact that a chemical engineer is interested in the economics of making that chemical, scaling it up to production size, dealing with all of those issues, as well as how do we actually bring a certain product to the market. And a chemistry major isn't necessarily as interested in that aspect. They're more interested in the fundamental properties of the chemicals and actually the synthesis and characterization in general of those types of chemistries. Both great areas, but that's just some of the differences. Another aspect to that is a lot of chemistry majors, when you come out with a bachelor's degree, most chemistry majors tend to go on to a graduate degree because they aren't as employable as a professional chemist. They would be more of a technician at that level, but they have to go on for a master's or PhD at that point. In terms of career opportunities for chemical engineers with a bachelor's degree, we do have probably over half, maybe close to 60% of our students go directly into industry, and about 40% go to graduate school of different types. There's a lot of crossover between engineering and management, as well as some of the other professional areas. If you are considering chemical engineering and are unsure, we do have this introductory course, ECHE 151. It's only offered in the fall, so do think about taking it then. And a common question we have is also about co-oping. We have probably about a third of our students participate in the co-op program, and a lot of students hear that that is, of course, a critical experience to have in order to get employment after the bachelor's degree. And indeed, it is a very important opportunity that you have. And we do recommend, if you do pursue that, to schedule it so that you start it in the fall of the junior year instead of waiting later, because it will create more problems for your curriculum by waiting later. But if you're not able to get a co-op, or you're not necessarily interested in the co-op program because it will extend your time as an undergraduate, there are other opportunities for you. And this isn't just unique to chemical engineering. This is for all engineering programs. Students work at companies for summer internships. They can complete research in the university or be involved with different types of design projects on campus. There's a lot of ways that you can distinguish yourself as being unique and show skills that are important to employers. So we hope you'll think about that even outside of class. And then lastly, chemical engineering also is a challenging program, just like biomedical engineering, but we do have a lot of students that finish in 4 years, with the exceptions, as Professor Seidel mentioned, related to other opportunities students may pursue.
Following up on experiences that are important for employment with a bachelor's degree, all the programs in engineering, chemical engineering and biomedical engineering, have strong components dealing with design and development. We want all the students to have hands-on experiences starting at the freshman level, and some of those would be definitely enhanced by a co-op experience and also internship experiences in industry. There is a special component of our educational process, which is enrichment via ThinkBox. This is now a new program in a special building specifically for designing and developing, testing products for commercialization. It's open to all students, and it is a very, very popular program and is not necessarily tied to any particular course. It is definitely an opportunity for students to explore and to develop and use special equipment such as 3D printing in order to in fact, produce products that are very inexpensive in order to have prototypes.
Lastly, we want you to realize that we want you to have a balanced program at Case Western Reserve, and we definitely stress academics, but we also want you to be involved outside the classroom with various organizations. So here's a sampling of student organizations that are affiliated with the different engineering disciplines. There's obviously many more groups than this that are more general to the student population, so we hope that you can try to establish a balance between being a great engineering student academically as well as being an involved student with the student community.
Now, here are the contacts by which you can reach us. I would encourage you, when you have a question, there are choices to be made and you're not sure about these choices, whether it's with respect to a particular set of courses or with respect to your future interests. You should feel free to contact either of us, and we'll be delighted to answer all of your questions. We look forward to seeing you in the fall. Good luck, and we hope you'll have continued success.